Hello, everyone. Welcome to another section. That is section 2.4, relative position of data. So we already discussed 2.3, and that was measures of variability. Sometimes we want to determine how dispersed and spread our data points are. So we have measures that will tell us how dispersed or spread our data points are. And we do so through the range, the variance, and the standard deviation. So today, talking about relative position of data, we're going to do that through the percentile, quartile, Bose and Whisker plot, and the Z-score. So first of all, with the percentile. So the percentile gives percentile rank to a data point in our data set. So for you to find the percentile rank of a data point in our data set, first of all, you need to arrange the data set from the lowest to the highest, then locate the points of interest. Now count the number of data points that are less or equal to that data point and divide by the total number of data points that you have. And afterwards, your final answer will be the percentile rank of that data point. That is how we determine the percentile rank of a data point S in our data set. Now, to the quartiles. So the quartiles divide your data set into 4 equal parts. So these data points that helps to divide our data set into 4 equal parts. We have the first, we have the second, and we have the third quartiles. We know how to find the second quartile, the Q2. The Q2 is the same as the median of our data set. So whenever you find the median of your data set, you have your data set split into 2 equal parts. Then you are going to have the lower set. We have the sets that are below that Q2, and we have the sets that are below that are above Q2. So we have the lower set and we have the upper set. We determine Q1 and Q2 through the lower set and the upper set respectively. So Q1 is the median of your lower set, and Q3 will be the median of the upper set of your data set. And we associate these with some kind of percentiles. So Q1 is the 25th percentile, Q2 is the 50th percentile, Q3 is the 75th percentile. All right. Now to the 5-number summary. We know how to find the minimum. We know the minimum of our data points. We know the maximum of our data points. And now we also know how to find Q1, Q2, and Q3. If you put these 5 numbers together, we get our 5-number summary. Okay, and we are going to use that to plot our Bose and Whisker plots. Okay. Now to the interquartile range. So when you talk about range, so we want to find some kind of difference between 2 numbers to know their interval. So the interquartile range is the Q3 minus your Q1. So we know how to find the Q3, we know how to find Q1. So get their difference and you are good to go. That gives you the interquartile range. All right. So we have some example here for us to solve based on the definitions that we've learned. So we have an example here to apply our definitions on. So with this data set, we have to find the 5-number summary. So the minimum, Q1, Q2, and Q3, and the maximum, and the interquartile range. So if you know your Q3 and Q1 give you a difference, you draw a Bose plot based on this 5-number summary. Then you have to find the percentile rank of the number 5. So the percentile rank, I repeat again, rearrange your data set from the minimum to the highest. Then locate your data set 5, your data point 5, and count the number of data points that are below or at 5 all over the total number of data points that you have, and that will give you the percentile rank. Okay, so let's see how we do that. So we have a link in our Canvas page that will help us get these 5-number summary. We've done that before. So whenever you have your TI-84 calculator, just input the data points that you have and go to calculate, like the same approach in calculating the mean. Then you scroll down with an arrow, you're going to see, and you're going to feed the minimum value, the Q1, the median, and Q3, and maximum. So the median is your Q2, and your Q1 is your first, the Q3 is the third quartiles that you are having. So this will give you the 5-number summary that you are looking for. Okay, so now to the interquartile range. So The interquartile range will be the difference between what your Q3 and your Q1. So we have it to be 9 minus what? 3. We have it to be 9 minus 3. So this is it. Now we have to draw the Bose and Whisker plots. So we are going to use the 5 number summary to do that. So first of all, locate your minimum. Your minimum is what? 2. So we have the minimum to be 2. So we do something like this. Very simple to do. So this will be your minimum part is 2. And your Q1, this is your Q1, and you have the Q1 to be 3. We have the Q2 to be what? 6. We have Q3 to be 9. Then you have the maximum to be what? 11. If you do this, you are done. So this gives you, so this is your minimum. This is your Q1. This is your Q2. This is your Q3. And this is what? Your maximum. That is what we want to do. Then we are done. Okay. Now, we have to find the percentile rank of the number 5. Okay, so first of all, rearrange your data points and locate 5. So we count the number of data points that are less or equal to 5. So realize that we have 4 data points divided by the total number of observations. So 4 over 10 gives you 0.4, and that's the 40th what? Percentile. That is the 40th percentile. We do same for this data points that you're having, then we are good to go. Okay. Now we have another example here. So I said rearrange your data set from the lowest to the highest. It's very important. So we have to find what percentile is the value 142. So after rearranging our data points, we had 142 to be here. So if you want to find the percentile rank of 142, then we count the number of data points that are less or equal to what? 142. Then we have 9 data points. So that is 9 over 10. So we are going to get 0.9, and that is the 90th what? Percentile. That is the 90th percentile. Okay. So what is the percentile rank of 126? So we locate 126. So this is 126. Then you count the number of data points that is at or below 126. So we have 4 data points that are at or below 126. So we have 4 over 10, and that gives us what? The 40th what? Percentile. The 40th percentile. Now, which measurement is the 50th percentile? Note that I told you that the 50th percentile is the median. So it's the same as Q2. So you locate the middle part of your data set. But if you count this data set, it's an even number of data sets. So then the median will be the sum of what? The 5th and the 6th divided by what? 2, and that is 134. So 134 will be what? Your median. 134 will be your median. Okay, so that's the 50th percentile. Okay, now we go to the z-score. So what the z-score does is that it's going to tell us in what number or in what units of standard deviation can we go above or below so that we can locate a data point. That is the z-score. So if you see a z-score and you're going to study the properties of what? The z-score. First of all, the data point should be from a normal distribution, that is a bell-shaped what? Distribution. By so doing, we can do that. We can use the z-score to get to our data point. Okay, and we have ways in calculating what? The z-score. So these are some properties of the z-score. A negative value of the z-score means that we are below the average. A positive value of the z-score means that we are above the average. And when z is equal to 0, we are exactly at what? The average. So we have a formula to calculate the z. That is our z-score. Okay. And that is giving us z equal to the s minus the mean over s. So we have the sample mean, the sample standard deviation, or the population mean all over the population standard deviation. Okay, so there's a diagram to help you get to know. So we have our s, that's this our raw data, and we have our standardized what? Score. So suppose we have a sample. Suppose a sample has a mean of 30 and a standard deviation of 5.4, but find a z-score of 35. So you want to find in how many standard deviation can we go above or below the mean to get to 35. So the z is equal to 35 minus the mean, that is 30, all over 5.5, and that gave us 1. So it implies that if you go one standard deviation, since z is positive, you go one standard deviation above the mean, then you're going to get to what? 35.5. That's the whole concept of it. Okay. Now you want to find, suppose a sample has a mean of 20 and a standard deviation of 1.8. What value of S would yield a z-score of 2? So now we have been given what? Z-score of 2. So we want to know, okay, since z is a positive 2, then we have to go 2 standard deviations to get to what? Our S. So how do we get our S? By the formula, we realize that, let me write it here. So we always have z to be equal to our S minus mu all over sigma. So by multiplication, we have this by sigma and this by sigma. So we are going to have z sigma to be equal to S minus mu. So we want to find what our S. So we add minus mu here, we add plus mu, and we add what? Mu here. So at the end, our S is always equal to mu plus what? Sigma plus z sigma. Okay. And we want to find this value. So now this has been given, this has been given, and this has been given. So how do you find our S? So the mean we have here is what? So this is what we are solving. This is what we are solving. We have the mean to be 20. We have our z to be 2. This is z to be 2. And we have our standard deviation to be what? 1.8. Note, if you are given the variance, take the square root of it before. If you are given the variance, take the square root of it to get the standard deviation. So if you solve this, then you're going to get our S to be 23.6. Okay, this implies that if you go 2 standard deviation above the mean, then you're going to get this value, what? 23.6. That is very simple to do. Okay. So these are ways in locating our data points. So we have an example here for you to check. So suppose you have a 43 and standard deviation of 2.6. You have to find what the z-score. So we have the z-score through the formula. We have the z-score to minus. This implies that you have to go 2 standard deviation below the mean to get to the number 37.8. That's the explanation to it. Okay. So these are some kind of examples for you to do. So here, we've not been given the mean, we've not been given the standard deviation, so we have to find the mean and the standard deviation. Because z, we need the mean and the standard deviation to find the z, and at that point that we also want. So you have to find the z-score of 3.98. What does the z-score mean? So you can input these data points in your, so this is a sample data, you can input this data point in your calculator, then you find the mean, then you find the standard deviation. That's the sample standard deviation. So there's the calculator approach. So we have the mean to be what? 2.645 and the standard deviation to be 0.86 and so on and so forth. So our z-score will be 1.50, so on and so forth. So this implies that if you go one standard 1.5 with those decimal points, units of standard deviation above the mean, then you're going to get to the number 3.95. Okay, we do same for the second question. We do same for the second question. Okay, so I have the explanation in the calculator way to do it. So note that when you are given the raw data like this, you need to find the mean and you have to find what? Your standard deviation. But at a certain point in time, you will be given the mean and you'll be given a standard deviation. Then that is very simple. But if you are not given that, then you need to find the mean and your standard deviation. And note that if it is sample, then you're going to use, if you are using the calculator, use S with a subscript S. And if it is a population, use the sigma with what? Subscript S. You're going to have the mean. Okay. All right. So I think this part is. So this was the question is, so we want to find what would it mean if a data point had a z-score of 0. Then it implies that that data point will be equal to the mean. Because if z is equal to 0, then by the formula, where is it? This student is exactly the same as the average. Okay, so it means that the student's GPA is exactly the same as the average. So we have S. So always you have S to be equal to what? The mean plus Z sigma. So if this is 0, then this part what goes off to what? 0. Then you're going to have S equal to what? The mean. Okay, that's why when Z equal to 0, then your S equals to what? Your mean. Okay. Okay, so suppose the mean and the standard deviation of all currently registered students. So you have the mean and the standard deviation, and you have the z-scores of 2 students. So Antonio and Beatrice. So you have their z-scores, okay, relative. What are their GPAs? So you want to find their S again. So by the formula, input this. So you have S, okay. Whenever you want to find back your data points, it's S equal to the mu plus Z sigma. But if you want to find Z, so Z is equal to S minus mu all over sigma. So this is finding back your S and this is finding what your Z. Okay, so if you want to find back our S, then, but here you want to use this formula. This is what you want to do. So for Antonio has a Z score of minus 0.62. So Antonio will be equal to, and we have a mean of 2.70, then plus the z-score of minus 0.62 multiplying the sigma of what? 0.50. Okay, so if you solve this, you're going to get Antonio's GPA to be 2.39. Okay, so that is for Antonio. We do same for what? For Beatrice. We do same for Beatrice and we are good to go. Okay, so there's the approach way. Okay, I'm taking time because this is something you are being introduced to for the first time. Okay, so I think that is that for section 2.4, and thank you for having time to look at this video. If you have any question, do not hesitate to email me and I'll be glad to respond to you. Thank you and have a wonderful day.